Ladies and gents, this is it, the last theory part of chapter 5, radical equations. We're going to take a look at theory C, and it's all about eliminating square roots from fractions. They say denominators, we also want them out of the numerator if we can. That most of the time is a bit easier. So that's why they say denominator, because that needs a bit more work. Okay, and let's switch to laser pointer. And this is mostly mathematical B again. You can simplify a fraction like 6 divided by root 3 to a form without a root in the denominator. And that's something that a lot of mathematicians really prefer. Again, you will see that in higher grades why. But we don't really like this root 3 here in this fraction. And we can get rid of this in a rather sly way. We can multiply both the numerator and the denominator by root 3. And I don't think the book really explains that well why you can do this. But here on the left I've written why you may do this. If I multiply the 6 and the root 3 by root 3, I might actually do this because I'm multiplying with root 3 divided by root 3. So I'm multiplying with the number 1, but in a very sly way. In Dutch, I was teach that we call this of in Dutch then, we call this vermenigvuldigen met een slimme 1. De 1 is op een slimme manier weergegeven, namelijk in de vorm wortel 3 gedeeld door wortel 3. And you can say in English, multiplying with a smart 1. It's not being called like that in theory C, but maybe you can call it like this. Multiply by a smart 1. A smart way of writing 1. Why is this a smart way? Well, if I now do 6 times root 3, I do have a fraction now in my numerator, but we will see that that's not that big of a problem. What I do in this way is get rid of the root in the denominator, because root 3 times root 3 is root 3 squared is 3. And now I can divide my numerator by 3. 6 divided by 3 is 2 root 3. This is one factor, right? So I only have to divide the 6 by 3. You don't have to, because this is one thing, I only have to divide 6. 6 divided by 3 is 2 root 3. So we want to get rid of the roots in the denominator, and most of the time that means it first will appear in the numerator, but then we can get rid of it. For example here, 2 root 6, here my smart 1, as I would call it, would be multiplying by root 6 divided by root 6. Then in the top numerator I find 2 root 6, and down below I find 6, and here I can rewrite this to 1/3 root 6. And then you say, well, how does this become 1/3 root 6? Let's take a look at this note here, because that explains a bit why this suddenly disappears. Just like 2/3 equals 1/3 times 2, we all agree with this, right? 2 times 1 over 3 is 2 over 3. I can write a divided by 6 as 1 over 6 times a. Right, the a can be any number, for example 2, like here, but we can split it like this. And we can also do that if I have a root here. If I have root 3 divided by 6, I can say that's the same as 1 over 6 times root 3. Why do I want that? Because now my root 3 is out of my fraction. So 2 over 3 divided by 6 is the same as 2 over 6 times root 3 equals 1 over 3 root 3. And that's here why in this case here the root disappears. 2 divided by 6 is 1 over 3. We put it in front, root 6. You can also do it like, I can show you in the lesson how you can also do a different intermediate step. But here, split it first, 2 over 6. 2 over 6 simplifies 1 over 3. Don't get too anxious about roots with fractions inside of them. First, convert this mixed number to an improper fraction. Breng de hele weer terug in de breuk. Root 5 over 3. Then here, the root of a fraction I can also write as the root of the numerator and the denominator. And then I'm going to multiply by my smart 1 again. And that smart 1, as I call it, is always just 1 written as the denominator divided by the denominator. So that's why here I'm dividing by root 3, divided by root 3 again, because root 3 is in the denominator. And then I get root 5 times root 3 is root 15. And here the root disappears. Root 3 times root 3 is 3. And here I can rewrite that as 1 over 3 root 15. Right, bang the root 15 outside of the brackets, just as we did here. I say brackets, but I mean fraction. Sorry. When simplifying square roots, use the largest factor possible, eliminate the square root from the denominator, and then eliminate the fraction from the square root. Okay, or one of them or all of them. Let's take a look. 6 divided by root 5. First, think by yourself, which smart one you can say am I going to multiply with? If you're taking a good look at the previous examples, I think we're going to multiply with root 5 divided by root 5. Both here, both here. This becomes 6 root 5. This becomes 5. So I get this. And now, this improper fraction I want to rewrite in such a way that the root is not inside of my fraction anymore. So rewrite it like this. Get this part in front. 6 over 5 divided by times root 5. And this, of course, is an improper fraction I'm going to rewrite as 1 over 5th root 5. Okay, so when they give you simplify as an exercise, they mean get rid of my roots inside of my fraction. That's something new that the book maybe doesn't really say, but simplifying means get rid of that, get it out of here. What's the tactic here? First, convert this to an improper fraction, the root of 10 divided by 7. Then remember the rule, you can rewrite this as the root of 10 divided by the root of 7 and then multiply it by root 7 divided by root 7 again, the smart one, because there was a root here, or root 7. This becomes root 10 times root 7 is root 70 divided by 7. You can say there's a 1 in front here, right? So I can rewrite this to 1 over 7 root 70. Now check whether I can or cannot factorize 70. Sometimes you can, right? So can I rewrite it this to root 4 times something, root 9 times something, root 16 times something? In this case, you cannot. Oh, sorry. In this case, you cannot. This one looks quite challenging. I want to get rid of this thing here, this root here. So I'm going to multiply the smart of this 12 divided by root 3 by root 3 divided by root 3. And here, 5 root 12 I can factorize because 12 is the same as 4 times 3. So here I've underlined which part is where to make it a bit comprehensive. So this is my part which was right here, multiplied by that smart one, root 3 divided by root 3. And here is the blue part being factorized in root 4 times root 3. Okay? This becomes 12 root 3 divided by 3. And this becomes root 4 is 2 minus 5 times 2 times root 3. Simplify this by dividing 12 by 3. Gives me 4 root 3. Right? 12 divided by 3 is 4. 4 root 3. And this becomes 5 times 2 times root 3 is minus 10 root 3. Are those like roots? Yes, they are. They have the same combination of letters slash numbers in their roots. 4 minus 10 equals minus 6 root 3. And then we are done. Okay? And with that, we have also taken a look at the last theory bits of chapter 5, with the new word being radical equation, wortelvergelijking. I wish you good luck with practicing this, and of course, feel free to ask questions during the lesson or send me a message in the chat of Teams. Good luck to you all.